morning 3K. So today we're going to continue with our fractions lessons, but we're going to do it in a bit more of a practical way. So you need to have some strips of paper. Make sure that they're all the same length if you can, because that's really important. Try and find some if you can, and then we can start the lesson. So you'll need your 3 strips of paper which are all the same length, all the same size, ready for the next part of the lesson. But before we start that, I want you to try and remember 3 things that you've learned all about fractions over the past week and a little bit. So again, write the short date and 3 little dots in the margin and try and think of 3 things that you can remember all about fractions that we've learned over the last few lessons. So let's have a look at our in focus task. There's a strip of paper here, and it's got some dashed lines down it. Why do you think they're there? What are they there to show you? So underneath is a question. Sam thinks that 1/3 can be written in other ways. Is Sam correct? You need to think about what the question is asking you to do. How can you work it out? And the strips of paper are a really big clue. And is Sam correct? Can 1/3 be written in other ways? So this is why you needed your bits of paper. Take 1 strip and I want you to fold it into 3 equal parts. Now I know this might be a little bit difficult, but do the very best you can. You need to make sure that they are all equal. So your 1 strip needs to be folded into 3 equal parts. When you've done that, I want you to shade 1 part, so 1/3. When we write 1/3 as a fraction, the 1, which is the 1 part of the whole that you have shaded, is called the numerator. The number that's on the bottom of the fraction is called the denominator, because that's how many parts there are that make up 1 whole. If you have a look at the picture of the 3 bits of the strip that you can see, it's got 1 bit shaded in green and 2 parts not shaded at all. So that's 1 of the 3 that are shaded. So in 1/3, 1 is the numerator and 3 is the denominator. Are there any other ways that we can write 1/3? Think about your fraction wall from yesterday, when we were looking at equivalent fractions. Now, I want you to take the same piece of paper that you shaded to make a third, and I actually want you to then fold it into 6 equal parts. So, then I want you to look at how many parts are now shaded. So you must use the same piece of paper that you used to do a third. So when you folded it into 6, how many equal parts make 1 whole? Yes, you're right. So 6 equal parts now make 1 whole. Let's have a look at the bit that's shaded in green on my slide. 2 out of the 6 equal parts are now shaded. So we can say that we now have 2/6. Remember, 2 is the numerator, and that's the top number of the fraction. It tells me how many parts are shaded. And there's number 6, which is the bottom fraction, is the denominator, and it tells me how many parts there are all together. So we've just worked out that actually 1/3 can also be written as 2/6. I wonder whether you could take the same bit of paper and you fold it now into 12 equal parts. When you've done that, see how many parts are now shaded and write that as a fraction. The fractions 1/3, 2/6 and 4/12 have different numerators and denominators, but they are all equal. If you have a look at 1/3, which is shaded in pink, and then 2/6, which is shaded in green, and then 4/12, which is shaded in yellow, if you put all those on top of each other, they would cover each other exactly. And that tells me that they are all equal. So, can 1/3 be written in different ways? Have a go at these questions. You don't need to use your strips of paper if you don't want to, because I've included a fraction wall and also some figures that you can have a look at in question 2 to help you work out the answers. Please use them, they're there to help you. So I've got a bit of a question to ask you now. But first of all, we almost know what our STEM sentence is. I know that the word equivalent means equal to. So I've got a number line here with 0 at one end and 1 at the other. And there are some lines, and above some of the lines are some shapes. I want you to use the clues to work out which fraction is being described for each shape. Then I want you to write what fraction each shape is worth. Can you record an equivalent fraction next door to each one? So, for example, how many parts make the whole? 6 parts make the whole. The triangle is above the second line. So, the second line is 2/6. Can 2/6 be written in a different way so that it is equivalent to something else? Have a go at this worksheet. Try and think about what each part is worth. When you've done that, I've got a bit of a challenge for you. A what if challenge. I've got a number line. My number line starts at 4/7 and goes all the way up to another number, which now has an empty box. So what would you put in the empty box and why? So here's your challenge. Brandon says that 2/6 is the same as 4/8. Is he correct? Explain your reasoning and remember to use the sequencing bubbles to help you explain. And I've put the sequencing bubbles on the next slide. So it's just a case of drawing some boxes, or even just do one picture and do a line to the next picture. I want you to try and explain your reasoning as best you can to prove whether Brandon is correct when he says that 2/6 is the same as 4/8. On the next slide, I've actually got some clues for you, but try not to use those. Try and see whether you can do your reasoning all by yourself first. We can discuss this in our 30-minute catch-up session later on today. Speak to you soon. Bye.